Welcome back to our revision in normal distribution. So now everyone know the standardized means z distributed normally for 0 and 1. So we state that mean equal 0 and standard deviation equal 1 and the variance is equal 1. And everyone know we just use the table to evaluate the area if the value of A is positive value and the area below or on the left. So if you have value of A is positive and the area on the right, we just use that 1 minus area below, because as you know we have only two things we use it to find the different cases. The total area under the curve is equal 1 and also the curve is symmetrical. So if the area on the right and the value of z is positive, we just do that 1 minus area on the left. Okay, if A is negative value, so we use symmetrical to take another value. Let's go to practice some past exam papers. In the first question here, he said, in a standard normal curve, the mean and the standard deviation, so mean first, and the standard deviation, which is sigma, respectively are, so we know that z distributed normally for 0 and 1. So mean equal to 0 and sigma is equal to 1. So it will be 0 and 1. In the second equation, in the shaded area is shown standard normal curve. We want to find that area, so we just do that. Area here on the right, so as you know the total area under the curve is equal 1, so it will be 1 minus the area below 1.43. So it will be 1 minus probability of z less than 1.43. And as we know, if z positive like 1.43 and the area on the left, we can use a table to state that. So to use a table here, we just look for the values of z. We just need to use the values of z. Z 1.4, so we're going to 1.4, that is 1.4. Then we're going on a row till 3, 0, 1, 2, 3, so that is the final answer, 0.9236. We just use a calculator to evaluate that.
The answer is 0.0764.
0.0764. It's finished. Now we are going to the next question. He said, find the shaded area in the shown. Now the same question and extended. In the next question, so the question here, it's like the previous one, but it's an extended. So mathematical written must to be exact. Now find the shaded area. That shaded area represents the probability of z above or greater than 1.16. So, and as we know, if that positive, or if z is positive and the area on the right, we just use 1 minus probability of z. We switch that sign to be less than 1.16. So we directly use that from the table, because now z is positive and the area on the left, because we search for that area on the left. Now we're going to the table 1.6, it will be here. Then we're going arrow 1.16, sorry, 1.16, that is 1.1. So we're going arrow till 6.
0.8770.
So that is 6, it will be 0.8770. We insert that in your calculator to get the answer. 0.123. So we need to complete it to be 4 decimal places every time. In the next question, we have very tricky question. In this question, he said, from the following standard normal distribution curve, if z between L and the M, so that is the values of z between L and M. has areas 0.6364, and probability of Z greater than M, which is here, that value, is equal to time that area. So that means I will divide the remaining area into three equal parts. One part represents Z less than M, and two parts represent Z less than L. All right? So everyone know the total area under the curve equal 1. So the remaining area, it will be 1 minus that area in the middle. So the remaining, it will be 0.3636. Now, to find the value of each part, because we divided the area into equal 3 parts, we divide that remaining area by 3. So the value of each one part equal 0.1212. Now we back to that relation. He said Z greater than M equal 2 times Z less than L. So Z less than L has one part, and Z greater than L, it will be 2 parts. It will be 2 parts, so multiply by 2. We need to find the area of the shaded region, that area of the shaded region, which is equal 0.1212. It's a very good question. Now we are going to the next question. Here I wanted to find the area between negative 1.2 and positive 1 over 2, and we noted that I have two values, one positive and one negative. So before I gave you tape to represent the curve every time, it's better for you. So assuming that is a normal distribution curve, so Z, so that Z, so the mean is equal to 0 in the middle, lies between two values. So assuming that is the first value in the positive 1.2, and I have the same value in the same distance from the mean, which is negative 1.2. Now we just use a table if and only if the value of Z positive and total area equal 1. Sorry, if the value of Z positive and the area on the left. We just use a table if the value of Z positive and the area on the left. Keep that in mind, then thinking for that. All of us know the area below 0, all the area below 0 is equal 0.5. And that area given using a symmetrical, we can divide it into equal parts. One part between 0 and 1.2, and the other part between 0 and 0.5. So why we make that? Because I just can evaluate the area of that part, then multiply it by 2. Why? Because here area below 1.2 minus area below 0. We didn't have any way, only one way to find the answer. So the probability of Z between 0 and 1.2, it will be equal probability of Z below 1.2 minus probability of Z below 0. So 1.2 from the table, it's 1.2, it's equal 8849, 0.8849. And as you know, everyone know that probability of Z less than 0 is equal 0.5. So the final answer, it will be 0.8 minus 5, it will be 3849. And you will find that answer, it's here, but that is wrong. Why, Mr. It's wrong? because I wanted to find the area between positive 1.2 and negative 1.2. We just evaluate the half of that area. So the final area here, it will be 2 times that value, 0.3849. So the final answer, it will be, I think, 0.6, and that is the correct answer. So you need to focus when you solve. Now we are going to the next question. It looks like the previous one, but here between 0 directly and 0.67, area between two values, one positive and one zero. So no problem for that. We just do that. Area below the biggest one minus area below the smallest one. We just do that. Probability of z below 0.67 minus probability of z below 0. We know that as a knowledge information, z below 0 it's equal 0.5. Now 0.67 from the table for 0.6, that is 0.6.
0.7486.
67, it will be 7486. 0.7486. So we just evaluate that. It will be 0.2486.
Yes.
That is. Now we are going to the next one. All I want to check if A positive or negative. Z on the right, so I will draw the graph. So that is the normal distribution curve. As you know, the mean equal 0. The area on the right and the given area less than 0.5, so it's not passed through 0, so the value of A it will be here. And the given area, that is, did you have any problem? He said the given area is equal value 0.025. To find the value of A or to use a table, the value of A must be positive, and here it's positive. But we need to find the value on the left. So since the total area under the curve exactly equal 1, so that white area, it will be 1 minus 0.025. So the result, it will be
0.975.
0.97. So the area on the left, 0.975. We complete the fourth by put 0 here.
Yes.
9750. Now A is positive and the area below 9750. Now we're going to search for that area 9750. We look for the areas now. 97, it's coming with the same order, so we start with 97 here. 975, 973, 973, 9750. That is 9750.
1.9.
So it's up 6 here
1.96.
and here
1.9.
1.9. So the value of A equal 1.96. That is my value. Now we are going to the next one. Here the given less than negative A. He said A is negative. So if he said negative, so he will state it in positive directly. So that means that is negative A. So any negative takes symmetrical, so the symmetrical line at positive A. Area here on the left include the same area on the right. So the area below A here, it will be 1 minus the given area. So 1 minus 0.064, it will be
0.9936.
0.9936. Now we look for that 9936 as an area opposite to what? 9931323436, that is 9936. Up we have 9 here, and the opposite it will be 2.49. We take it with positive value, we didn't take it with negative. Why? Because he said here it's negative. If its root as z less than positive a only, so you must to write a equal negative 2.49. But because here negative times negative, it will be positive. So we did like that. Now it's clear. Let's go to question number 12. And that question number 11, it's a very good question, and it's also a tricky question. So, to repeat that, it's necessary here to draw the diagram. As you see. So the bell curve it will be like that. He said z lies between two values. One negative and one positive and the same value. So that means I have here 0. Z lies between two positive value. So positive and the negative. So if you have positive a here, the negative it will be have the same distance from the mean, that it will be negative a. And the head said the total area here is given by 0.9098. What we have to do to state the value of a here? As you know, we just use the table if the value is positive and the area below. And since we have the same value here, one positive and one negative, so the area between 0 and the positive value a represent the average of that area, or the half of that area. So if you want to state that area only between 0 and a, it will be the given area 0.9, sorry, 0.5098 divided by 2. It's equal to
0.2549.
0.2549. So that area, it's 2549. And the area below 0, it's equal 0.5. So the total area below A, it's equal the area between 0 and the A, which is 0.2549, plus the area below 0, which is 0.5. So the final, it will be 0.7549. Now we look for that inside the table. 7549, 7549. It's ordered with the same number, with the same 7575, 7549.
0.69.
7549, that is.
0.69.
So it will be 0.69. So the value of A equals 0.69. So that area included between 0.69 and negative 0.69. Now we are going to the next question. He said from the following standard normal distribution curve, find the value of A. It's a very good question also, because I know that is the value of A. Then from the following standard normal distribution curve, find the value of A. So we just use the table if you know the all area below A. But we know that the area below 0, it's equals 0.5. So from that shape, that means probability of Z less than A equal the area between 0 and A, which is 0.3962, plus 0.5, so it's equal 0.8
962.
962. Now A is positive, and you know the total area below that value, it will be 0.8962. Now we look to the table to find the value of A. 8962 from the table, 8962, 8962, that is value. It will be up 6,
1.26.
so it will be 1.26. In next question, if the random variable x distributed normally for 35 and 9, then the values of mu and the sigma. That is standard. The variable here is x. It's not standardized. So always we write the mathematical notation x distributed normally for mu and sigma square. Why? To compare that with the given and state the values of mu. What is the value of mu? It's 35. Sigma squared equal 9. Attention for that. Sigma squared equal 9. So sigma, it will be root of 9, which is equal 3.
Yes.
But here he wanted to find mu plus 2 sigma. Now substitute. What is the mu, which is mean? It's 35. Plus 2 times 3, it's 6. 6 plus 35, it will be 41. That is. In the next question, the random variable x distributed. Here is x, not z. So we just use that formula. Z is equal x minus mu divided by sigma. To transform from x to z, we use that. But first of all, I will write mathematical notation to state the value of mu and sigma. So it will be x distributed normally for mu and sigma squared. Now compare that with the given. So the mu equal 72 and sigma squared equal 8 squared. Here sigma squared equal 8 squared, so squared it will be cancelled, so sigma equal 8. Now to find that expression, probability of x less than 74.4. First of all, we look for that x. So to transform that x to z, we just use that rule, where the value of x equals 74.4 minus the value of mu from the given, it's 72, divided by the value of sigma, which is 8. Now it's equal probability of z below or less than
65.4.
65.4 divided by 8.
Yes.
So it will be 0.3. Now we are going to sketch the diagram. The mean in the central location, it's at 0 because it's changed to z now. The value of x here changed to be in z equals 0.3. Z less than, so the value is positive, and we want to evaluate area less than, so it's on the left. So we just do that. Z positive and the area on the left, we just take it from the table. 0.3, only 0.3, so that means 0.30, 0.617, so the final answer 0.6179. Then hashtag we love math. Now we are going to the next question. He said the random variable x. I got x again. X or y. Mathematical notation. X distributed normally for mu and sigma squared. Y, to state the values of mu equal 48. Sigma squared equal 10, so sigma equal 10. Now to evaluate probability of 41 x between 41 and the 49. So first of all, we look for that x. So x is changed to be z using the rule. The value of x here, it's a 41 minus mu 48 divided by sigma, which is 10. The value of x here, 49 minus 48 divided by 10. So we got that the probability of z lies between 41 minus 48, negative 7 divided by 10, it will be negative 0.7. And here 49 minus 48, 1 over 10, it will be 0.1. Now we're going to represent the diagram. So in this diagram, I have z lies between two values, the mean in the middle, 0, negative 7, it will be here, negative 0.7, and 0.1, it's close to 0, it will be here 0.1. We just want to state the area included between the two values. So as we know, it's always, if you have area between two values, we just do that. Area below 0.1 minus area below negative 0.7. So it will be probability of z below 0.1 minus probability of z below negative 0.7. So from the first one, 0.1 is positive and the area on the left. So we can state that from the table, 0.1, it will be 5398 minus. But for this one, I have problem. Take it with green. Z below negative 0.7 means I want to find that area. And any negative, we use symmetrical. And as you know, in symmetrical, if the area on the left, in symmetrical, it will be on the right, but with the positive sign. So that it will be 1 minus probability of z below positive 0.7. Now, we just do that, 0.5398 minus 1 minus state 0.7 from the table, it's equal 7580, 0.7580. Then insert all of that in your calculator to get the final answer. Then hashtag we love math. Now we are going to another value. He said from the diagram, if the random variable x is distributed normally for 20 and 5 squared, find the shaded area. So it's got, here it's coming in x. So we need to use that for z equal x minus mu to change it to be n standardized. First of all, I will compare that with the mathematical notation for standard normal distribution. It will be mu and sigma squared. So that means the value of mu is equal 20 and sigma squared equal 5, so sigma equal 5. Now to find the probability of x between, always we start with the smallest one from the left, it will be 13, and the highest it will be on the right. Here x lies between. To change that x to z, we use a formula. 13 minus mu, which is 20, divided by sigma 5, and here x, which is 20 minus 20, divided by 5. So it will be probability of z lies between. That 20 minus 20, it will be 0. That 13 minus 20,
negative 1.4.
Negative
1.4.
1.4.
Yes.
So that it change it to be 0, and that it change it to be negative 1.4. So any symmetrical or any negative take symmetrical, It will be positive 1.4 here, and included the same area between the 0 and the positive value, so it's equal the probability of z between 0 and 1.4. So we just do that, area below 1.4 minus area below 0. So 1.4 from the table, it will be 9192 minus area below 0, it will be 0.5. So the final answer here, it will be 0.4192. It's finished.